need help, but it's there if you would need them. All right, so what's the rule for dividing fractions? Drew?
You gotta
Multiply by their reciprocal. Very good. So I have 2/5 times 9/7, and then nothing I can cross reduce, so I just have to multiply. So that would be 18/35. I checked to see if I can reduce that one, which I don't think I can, so that is it. I am done. Okay, second one, I taught you about complex fractions. How do you do complex fractions?
When I looked at it, I saw because it's like, well, I see like 6 divided by 8 times.
Yeah.
8 times.
Yeah, it's just a division problem, okay? We've taught it before, or I've taught it to you because it's back there, and I don't write them up there until I teach them to you. So complex fraction, this was quite a while ago, but this is a fraction within a fraction. So 6/7 divided by 8/9 is how you would write that, and then you just do the exact same thing again. So 6/7 times 9/8, and I like to cross cancel, so is there anything I cross cancel? 6 and 8, good. So this would be a 3, this would be a 4, and now I can multiply straight across. So 3 times 9 is 27 over 28, which can't be reduced. Is that coming back? Do you remember doing that now? Yes, Jake.
You get the same answer.
You will. You'll just have to reduce at the end. Does that make sense? Yeah. So you would take 6 times 9 and 7 times 8, and then you'd have to reduce both. Okay. All right. Next one. You guys should be good at this, right? Each makes a number in proper form. So 2 times 5 is
10.
10 plus 4, 14. So 14 over 5. And 3 times 4 is 12, plus 1 is 13 over 3. Okay, any questions on that quick review before we get going? Okay, very good. Okay, so learning goal today. I've gone ahead and combined 7-3 and 7-4 because they're kind of like yesterday where they kind of go together, and I think they're too short to do by themselves. Did you guys feel okay with yesterday? Doing the work? Would you think you would have needed 2 full days? That's what I was afraid of. So if we get through this and you feel like we need another day for me just to help with something, I can do that. But I went ahead and combined both these lessons. The student will understand how to simplify ratios, rates, and unit rates. And I want to review that vocabulary with you from yesterday because I want to make sure you really understand what each of these are, because these are the 3 things we talked about yesterday. Okay, so the first one is a ratio. Okay, a ratio has to have the same units. Okay, same units. So if I wanted to compare yesterday, it was bowling pins, and it was like how many are standing to how many are knocked down. That's a ratio. Okay, or it was comparing, what was another one? What was it? Okay, feet and yards couldn't be a ratio because that would be, and we had to switch them. Very good. And that was the big thing. We had to make sure they were in the same units. Okay? When you get to rates, okay, rates can have different units. Okay? And examples of that, it was talking about like gasoline in a car. Like if I say my car holds like 16 and a half gallons of gas, so I can do 300 miles on 16 gallons, that would be an example of a rate. So if I said, 300 miles, 16 gallons. Okay, that is now a rate because they're different. Eric?
How do you write the keywords down?
Keywords.
Like ratios is 2 and rates is 4.
Okay, you can do that if you want. Ratios, we look for that word to, sure. And rates is usually per. Sure, we can do that. Okay, then we talked about unit rates. What specifically were unit rates? Rates that are units, yeah. Eric?
Find the rate of only one of the things you're comparing.
Yes. So they are still different units. Still different units. But it's per one. That's the big key thing. So rates and unit rates, both different units. It's just per one thing. So that's where I would change it to say that my car might get 30 miles per gallon. Okay. or if I'm driving in my car, 70 miles per hour. Okay, that's what changes it between the two. Okay, so those were the big three things we talked about yesterday. All right, so let's look at what we're going to do today. All right, so I wanted to point out on this one that this one is talking about a ratio. An athlete runs on a treadmill for 3/4 of an hour. The athlete then lifts weights for 2 hours. Write the ratio, so it's both in hours, of the running time to the weightlifting time. So remember that tells us the order. Okay, so we start with running time, which was 3/4 over weightlifting time was 2 hours. They're already in the same units, so I'm good. Then how would I simplify this? I would divide. Because remember, you had 3 ways to write it. You could use the word 2, you could use that dot, or you could use the fraction. Okay, so now we're going to simplify this, and we're going to say 3/4 divided by 2, and then we're just going to work it. So 3/4 times 1/2, and then multiply straight across. So 3/8.
Why is it 1/2?
Okay, who can explain why it's 1/2?
Find the reciprocal.
Very good. So because it's keep, change, flip. You find the reciprocal the second one you multiply. Okay, does that make sense? Yeah? Okay. Alright, let's move on to the next slide. Alright, write the ratio 3/4 of a gallon over 9/10 of a gallon in simplest form. So you guys go ahead and try that one and then we'll check it. Alright, so this is our divide by. So 3/4 divided by 9/10. Alright, listen. So 3/4 times 10/9. Oh, I don't know why it's there. Whoopsies. Okay. Okay. Alright, and then I can cross cancel some stuff, right? So 3 goes into 3 once, 3 goes into 9, 3, 4, let's see, 2 goes into both of these. Do you have to do it this way? No, you don't. 1 times 5 is 5, and 2 times 3 is 6, so I'm getting 5/6. Is that okay? Alright, very good. Now, if you did a different way, that's totally cool. You just had to reduce and get 5/6. Why, what? You reduced one of them? Oh, one of the cross reducing? Yeah, you can do that. But then you had to reduce at the end, right? Yeah, that's fine. Alright, so next one. Professional football field is 53 1/3 yards wide. Find the ratio of the width of the actual field to the width of the field in the poster as a fraction in simplest form. So I gave you a huge hint on this one, that this one is a ratio. So what do you have to do? Same units, okay? If it were a rate, you wouldn't have to. Does that make sense? So ratio, same units, rate, you don't have to. Okay, so let's see, what are we supposed to do? Find the ratio of the width of the actual field. Here's our magic word 2. So what's the width of the actual field? 1.5. Think about what you just said. How big is 1.5? Yay big. This is how big the football player would not even be able to fit on the field. 53 1/3, right? Yards. Good. Okay. Then it says 2, the width of the field on the poster. So here's my poster. It's at 1.5 feet. But again, I'm in ratios, so they have to be the same units. So what do you want to convert here, Jeremiah?
The bottom one is half a yard.
Okay, good, because there's 3 feet in a yard. If you didn't know that, where would you look? Internet, good. Okay, so if it's 1 1/2, that means it's really only a half of a yard. So is it okay with you if I go ahead and say this is half yard? Is that okay? All right. So now we're going to set up our problem, right? We have 53 1/3 divided by 1/2. So what am I going to do with the 53 1/3? Proper fraction. Good. So 53 times 3. We're getting 159 plus 1. So 160 over 3. Now, Catherine, what do I have to do to this part?
You multiply by the reciprocal.
Very good. 2 over 1. Okay, anything I cross cancel? No, unfortunately not. So I'm just going to have to multiply. So let's see. Straight across would be 320 over 3. And then I need to change that back into a mixed number. So how many times does 3 go into 320?
106.
106. And 2/3? Okay, I'm going to trust you. This is Eric. And my units here, yards. Whoops. Going out of my record space. Okay? Yes.
I don't get how you got a half.
Okay, because there's 3 feet in a yard. So if I have a full yard, let's pretend like this is a yard, there's 3 feet in there. So if I have a 1.5 feet, that's a half a yard. That makes sense? Half of that. Okay. Now a lot of people would choose just to multiply this by 3 to get them to all feet. Okay? But then, yeah, so either way is totally fine. All right. Let's keep going. All right, now here's the next part of this. Now we have switched into rates and unit rates. Does this look the exact same?
Yeah.
Yeah, what's the only difference?
It's
Different units, but isn't this what I just taught you? That's why I'm doing it all in one day. Because the only difference is that they're different units. Is it okay to be in different units here?
Yep.
Yes. Okay, so remember, rates are different units. Rates, different units, but to 1. That's the only difference. Okay, so to get something per 1, if I do a half a mile in a 1/4 of an hour, I just need to divide them to get them to 1. Okay, so I'm going to take 1/2 divided by 1/4. So 1/2 times 4/1 is,
So you only switch around the second
you
one.
only do the second one, 4/2, which is 2. Now, let's see if this makes sense. 2 miles per hour. Now look at what it told us from the beginning. It said I could do a half a mile in a 1/4 of an hour. So if I had a clock, right? Does that make sense? I could do a half mile here and a half mile here. How much is that? And then another half mile and another half mile. Equals 2 miles per hour. Does that make sense? Like if you just think about it, that's what you just did. And now we found a unit rate. Yes.
Also, this may not make very much sense, but 1/4 times 4 is 1, so that's the 1 mile. I mean, that's the 1 hour, and then 1/2 times 4 is 2. He's going to confuse me.
Yeah, that's fine. All right, go ahead and try B on your own. Bam, it's magic. It's already done. All right. Now, I think this is the one that my other classes really struggled with when I taught this to them, was problems like this. So if you have questions as I'm doing it, make sure you tell me so I can help you. So as you're running a fuel economy study, do you know what that would mean? What would that mean? Yeah, is that important to a lot of people? Yeah, especially when gas gets really expensive. Okay, which car can travel the greater distance on 1 gallon? That would be a really real life thing to think about. Okay, so if it travels 18 2/5 miles and it uses 4/5 of a gallon, that's exactly what we just did on that last slide. That's saying I have 18 2/5 over 4/5 gallon, because this bottom part is what I want to get to 1. Yeah, that just got recorded, by the way. Okay, all right. So, does this make sense how I set that up? Now, I'm going to set up the other one, and then I'm going to divide you guys down half of the room, and I'm going to have each of you guys work it, okay? So, this right here, if you were on this or this way, do that one. This other half of the room, do this one. Okay, so from that side, do the second one. All right, so what did we get on this side from this half of the room? What did you guys get? 23 miles per gallon. Do you guys all agree? Okay, so 23 miles per gallon. Here would be the abbreviation in real life. That's what you'd use. Okay, car B, what did you guys get on this side of the room?
We got all
All different.
I don't know how to do
Okay, so 28 divided by 1 1/4. Okay, so 28 times 2 is 56. Okay, so I'm getting 57 over 2 times 5 over 4. I'm going to switch that to 4/5. This half of the room? We okay? All right, so did anybody get this far? Can you now tell me if your answers? Okay, what did we get for an answer then, Jake?
22 and 4/5.
22 and 4/5?